Hey fam, welcome back. And in today's video, let's do something different. Rather than going through DSA, what we'll do today is see an algorithm on word search. Word search, as the name tells, if we are given a sentence and we have to find a specific word, then obviously these kind of algorithms are used, like word search. And the thing is, there are many algorithms to do that, and one of them is KMP. But obviously KMP is really hard and requires dynamic programming and all, which not many will know. So we'll see a lesser version of that, which is rolling hash. And the ideology of rolling hash is not that complicated to comprehend. What we'll do is first we will convert the entire given word which we have to search to its corresponding ASCII values and add it up. And then again we'll go through the given sentence letter by letter, and we'll have another variable called anything. For example, let's take it sentence check, and which keeps on adding the value of the ASCII value. And if by in any instance if the sentence check becomes equal to word check, or the ASCII values become equal, then obviously we can do a one-to-one comparison. So this takes down the complexity from O of n times m, where n is the length of the word and m is the length of the sentence, to O of length of the sentence itself. And yeah, this is really optimal to use in very large sentences and all. So let's go through that. So like how will you start? First let's define the function. And yeah, one of the best practices to do is define it in such a way that what we are doing is defined itself in the function itself. For example, it's better to not define things like def a and all, mainly because yeah, if you are the person who has written it and you will know what it is, but when someone else is reading, then obviously they will not know what a is and what it is, and they have to go through the entire code, which will directly be hassle. So yeah, what will we get? We will get a word and a sentence, from where we have to check it. So yeah, so let's define some variables. First let's define check word, which obviously holds the ASCII values of every character in word. And then we have to check sentence, which again I have explained will hold the ASCII values of each character of sentence, and it also has some pre-processing which we will do. And then let's also calculate the word and sentence length. Yeah, and what will it be? It will be obviously length of word. Yes. Now yeah, first let's calculate the value of check word, which is the addition of ASCII values of each character of word. So for I in word, plus is equal to, what we'll do, old. This is how we convert characters to its corresponding ASCII values. Yes. And what we have done is we have compiled the value of every word as its corresponding ASCII character. So now what we have to do? Now till the word, first what will happen if the given sentence is if the given word is this and the sentence itself is, yeah, what we see is that directly the first 5 words are the given word itself, first 5 words of the given sentence. So we have to check for that condition in a separate case. So what we'll do is first we'll iterate through character by character of sentence till the length of the word. Yeah, length of word, which is calculated as word length. What we'll do, check sentence plus is equal to order of the value I, not I, it will be a big mistake. So sentence at the position I. Yes. So now we have to do we have to check if the current sentence itself is equal to the current word. If check sentence is equal to check word, then what we have, if it is equal to each word, then what we can do is we can compare it character by character and check it out. So what we'll call it as check letters, check the individual letters of what we have to check? The word and the sentence from where. This is also important to note, that we will not check for the entire sentence itself, but we will go just till the length of the word, from 0 till length of word, which is word length. Yeah, let me define that. Yeah, what will get word and then a sentence. And to keep the code clean, let me define a variable I also. Yeah, no, it's better to do like this. Then go through each character of word, and if word at position I is equal to sentence at position I, then we can continue. But in the condition, if it is not equal, then what we have to do? Return false, and telling that yeah, the given word is not equal to sentence, or and then we can return true. Yeah, what we can do is we can also do this also, but hey, let's do it verbose rather than directly returning some stuff. And yeah. Okay, and now you check, yeah, if it has returned true, then we have obviously found the word, so yeah, we can directly return true. Or else what we have to do? Go through each character, but from where to where? Since the first 5 characters are already checked, or the first 10 characters, or the first length of word characters are already checked, we have to go from the word next to the length of word I, from word length to sentence length. So now what we have to do? We have to be logical about it. So if we directly keep on adding the current ASCII character to the check sentence, then obviously it will keep on increasing. But how do you restrict it? The best way to restrict it is to subtract the value at the position I minus the word length. So why am I doing that? Let me write out the. Okay, let's do some example. World. Yes, consider you have this sentence, and yeah, consider the ASCII value of. Just consider to the ASCII value of check word over here. Let it be 100, and yeah, first we'll check the first 5 characters, which is world, and let it be something like 60 or something. And yep, we'll check. Okay, it's not correct. So what we have to do? We have to add the value of h and remove the value of w. So why am I doing that? So we'll add the value of h and remove the value of w. It might become something like 90 or something. And again we check if the check word is equal to current check sentence, and if it is not, then yeah, again we proceed. And why we do that? Yeah, consider we are over here, and after we remove the value of d and add o, what will happen? The word check sentence will have the ASCII value of hello. Am I right or wrong? Because you are continuously decrementing or removing the values of r, o, w and all, and you are adding the value of e, l, o, etc. So first we remove the value of w and we add the value of h, and then we remove the value of o and add the value of e, and then we remove the value of r and add l, we remove the value of l and add l, and we remove the value of d and add o. So what has happened is we have actually reached hello itself. So now we have to check individual character by character, because there might be some instance where the ASCII values might be equal, but the word itself might be different. So for that checking, we do the check letter. Let me remove this. Okay, yeah. So let's do what I told just now. So check sentence, what we'll do? We'll take the check sentence, the value which it had, and plus what we'll do? Order of sentence at the position I, and minus order of sentence at the position I minus word length, as I already showed how. And then again, if check sentence is equal to check word, then what to do? if check letters is true, then we can directly return true. Yeah, again over here what we have to send? We have to send the word to check, and then we have to send the sentence, but not the entire sentence, just the part where the ASCII values were equal. And how do you do that? What do you have to do? Sentence. You have to take the sentence from which position? From I minus word length to sentence length. Yeah, the thing is we can directly send till the end of the word also, and it won't have any effect on it. But yeah, and because it's 0-bit indexing, we have to add one over here, or else you will obviously get wrong values. And then yeah, if it is true, then return true. And yeah, this is basically the entire algorithm. Yeah, and over here what I'm doing is consider if I have hello, and the given word is, if it was like this, then just rather than just sending, yeah, we can, and the thing is we can actually remove this also to make it more easy to understand. So what I'm sending is I'm sending this and entire this part rather than just this part. Rather than just hello, I'm sending the entire hello world. And if it was hello world, then what I'll be sending is hello world. We can do an optimization just on this part also, but yeah, that is some extra unnecessary code which does not improve the time complexity by that much. So we well, it's written false. Now let's check if it works or not. And then put God over here, and what would search God in where, and let us check if it's true or not. Oh yeah, this makes no sense. We don't want to print God and then the sentence. You have to check it, no. Boolean hash of God and sentence. Oh my god, it is telling that Python interpreter is wrong. So yeah, let's use some default Python interpreter. Yeah, let's use 3.11. There's no issues with that. And yeah, true. It's telling God is present, but if we do God or something, yeah, it's obviously coming to be false. And yeah, okay, a bonus clip for you. Let's have some very big sentence like which has like 1000 characters. Like consider let it be a, and then it will have God. But how to do that? We are living in 21st century, and so let's not brute force that. What we can do is write a Python script to do that for us. So yeah, create .py. Yeah, create type.py. So what we have to do? We want a sentence. Yeah, let me not do dumb typos. So yeah, now let's open our file with open text.txt. How do you want it to open? You want to open it as a write format, as if, yeah. So we are opening a file called text.txt in write format. So what this will do is if the file is not present, then it will automatically create a file, and then in file what we want to do, we want to write the sentence, and then dot write what will write some check like DSA. Let's write DSA time. Yeah. So now let us populate a sentence. So for I in range, let's have 10,000 words, and sentence plus is equal to what we'll do, random character like a, and let's make the test case more clean so that we can go through it once. So if I modulo 100 becomes equal to 0, then what we can do is then plus is equal to break line character. Yeah, now this should technically work. Yeah, see, the text is created and it has a, and at the end it has DSA time. So let's check it out. Sentence. Now what we have to do over here? This, then with open. What we want to open? Text.txt, and we can open it as read or write. It does not matter. Let me open it as read, as intended, rather than doing weird stuff. Sentence is equal to file.read. Is equal to file.read. Yeah. And now just let us just check what sentence says. And lo and behold, it has read the entire file and all the contents in it. So yeah. Now what we'll do? Rolling hash of what was it? DSA time. DSA time and the sentence which you want to check. Sentence. Yeah, it's telling true. Telling that yeah, if DSA time is found, but if I just make it DSA tim, it will obviously not work. And if I just make it DSA, it should work, because technically the word has, because DSA is present over here. As it is pretty obvious. And yeah, this is like really quick, and there is no overhead and all. Let me run it as Python file. Let me run it as code to get the time. It took 0.2 to 5 seconds.